Hello students, Jai Hind, and in the mathematical tools section we have completed differentiation, and in this episode we will start with integration, right? So this is another mathematical tool and it's pretty simple, students. I mean, if you are aware of differentiation, then integration would be just the inverse of differentiation. But before we start with the actual topic, we need to graphically understand the importance of integration, right? Where it comes into play, where we need to use this integral calculus. For that, let's consider y as a function of x. This we have already considered in the differentiation as well. I have told you this is read as y as a function of x. That is, for any given value of x, y will have a definite particular value. Y is also variable, x is also variable, but the value of y depends on x. That is, x is known as an independent variable, but the value of y which depends on x is known as a dependent variable. Now suppose, let us consider this to be xy graph, and if you plot y equals to fx, suppose the graph comes out to be like this. Let us consider this, right? So, let's draw perpendicular to the x-axis. This is suppose A, and let us consider this to be B. And also, students, suppose consider these 2 points P and Q on the curve which are lying infinitesimally close to each other, right? Now look, first and foremost, this is a bounded figure and it's not of symmetrical shape. It is of irregular shape, asymmetrical shape. So we are not aware of the formula to find its area. There is no such formula which we can directly apply over here so as to find the area of this geometrical portion, isn't it? So here comes the role of integration. By integral calculus, we can find out the area of this portion. We can easily determine the area of this particular portion, which otherwise is extremely difficult to find the area because of its irregular or asymmetrical nature. So, how to find its area? Let's first discuss that. So, what to do is, we will divide into n strips, any number of small rectangular strips. So, let us consider one such rectangular strip. So, I am considering one such rectangular strip. I am talking about this particular strip. I am talking about this strip, right? This is any arbitrary strip. And let us consider the coordinates of P are x and y, while the coordinates of Q are x plus del x and y plus del y. Del x, del y, you are aware, it shows small change in x, and del y shows small change in y. So students, this is the origin. This distance is x, this distance is x plus del x. So what will be this distance then? It will be del x. Again I repeat, the coordinates over here are xy. This is x, this is x plus del x. So this distance would be del x. Similarly, this is y, the vertical distance, and this distance is y plus del y. So this small distance would be del y. This small distance would be del y, this one. Am I clear? So, we need to find out the area of this entire thing. So what I have told you is, we will divide into small strips. These are the strips I am talking about. This is the first strip, this is the second strip. Suppose this is the ith strip, and let us consider this to be the nth strip. This is suppose the nth strip. So we can divide it into a large number of rectangular strips. So the sum of all these strips will give us the area of the entire portion, isn't it? It will give us the area of the entire portion. So student, basically this is A, B, C, D. So area of A, B, C, D, it can be written as summation I equals to 1 to n, we are considering n strips, into area of this one, ith one. What is the area of this one? It will be del x multiplied by del y. Now look students, since this strip is considered to be very small, so it can be considered to be of length y only, because del y is negligible, so it can be considered to be of length y. because we are dividing it into very small width rectangular strips. So these 2 points lie very close to each other. So as a result, the thickness may be considered to be y. So what about the area of this portion? It will be equal to y into del x. So further it can be written as summation I equals to 1 to n. What is y? It is fx. fx del x. Is it clear? So again I repeat, suppose the curve for y equals to fx is like this. So if we intend to find out the area of this portion, we need to make use of calculus, integral calculus. So for that, first and foremost, what we have done is, we have divided the entire portion into a large number of small rectangular strips. This is any arbitrary rectangular strip having width of del x and length of y, right? So if you find the area of this rectangular strip and then do the summation, then that will give us the total area of this portion. That is what we have done. Summation I equals to 1 to n. Area of this one arbitrary rectangular strip is y into del x. Y can be written as fx. So that will give us the area of this entire portion, right? Now look, here what we have approximated is, we are taking limiting case. This y on both the sides would be same only when del x approaches to 0. Only when del x is very small. Here I have considered the length of this rectangular strip to be equals to y. So del y will approach to 0 only when del x approaches to 0. So if del x approaches to 0, then our approximation would be justified. So in the limiting case, when del x approaches to 0, these 2 points lie very close to each other. In that case, the length of the rectangular strip, which we have considered to be y, will be logical and will be justified only when del x approaches to 0. And in the limiting case, when del x approaches to 0, then this summation gets changed to this form. This is actually the expanded version of summation, which is known as integration, and it is written as fx, and del x, in the limiting case, del x is written as dx. So this is, student, integration of fx with respect to x. This is the symbol for integration. Actually, summation, it is denoted by capital letter x, s. Now if you expand it, simply if you try to expand it, it will be like this. So the symbol for integration is expanded or stressed s. So integration is nothing but it is the extension of summation only. Addition of small parts. That is to integrate, to combine, to fuse together, to combine together. So that's integration point. So this is the proper representation of integration. And what about area then? Area of ABCD. It will be given by integration of fx dx, and what are the limits? It is from a to b. So these are known as the limits. This is known as the lower limit and this one is known as the upper limit. In case the limits are absent, then that integral is known as the indefinite integral. While if the limits are included, just like in this case, then it is known as definite integral. So again I repeat, integration is basically the extension of summation. Here, in order to find out the area of this entire portion, we need to determine the area of the small rectangular strip. So in the limiting case, when del x approaches 0, then the length of this small rectangular strip on both the sides can be considered to be y. In that limiting case, the integration of area of this portion will give us the area of the entire portion, which is represented by this symbol. Right? This is read as integration of function fx with respect to x. So that is how it is read. Okay, let's proceed further. Now let's come to the actual definition of integration. Now look, students, in differentiation what we did was, when a function is known, then its derivative can be found using differentiation process, isn't it? Integration is a process of obtaining the function when the derivative is known to us. I repeat, integration is a process of obtaining the function when its derivative is known to us. Clear? And this is the reason why integration is known as the inverse of differentiation. Integration is the inverse of differentiation. So mathematically, I'll convince you. Mathematically, if differentiation of fx is suppose f dash x, then integration of f dash x with respect to x would be equal to fx plus c. C is some constant of integration. That also I am going to justify, right? So look, before that, let me again try to convince you. The differentiation of fx is f dash x, then the integration of f dash x would be fx. So if the derivative of a function is known to us, then that function can be known from its derivative, and that process is known as integration. Obtaining function from its derivative, that is integration. That is the reason why integration is also known as the inverse process of differentiation. Now regarding this term c, constant. Now in this case, even if you write like this, if differentiation of fx plus constant would be also equal to f dash x. Differentiation of fx is f dash x, therefore differentiation of fx plus any constant would be also the same, because students, differentiation of constant is always 0. Therefore, integration of f dash x would be equal to fx plus c. That is what I have written. So, this derivative can be obtained either by differentiating fx or fx plus some constant. So that is why here the constant is to be introduced. In the case of indefinite integral, where the limits are given, then you will obtain a particular numerical value. So no need to apply that constant, right? But in case of indefinite integral, where the limits are not given, this is absolutely mandatory to write c or k, which is the constant of integration, right? So students, again I repeat, if the differentiation of a function is given, then the derivative, from that derivative, the function can be obtained by using integration. Or in simple language, if the differentiation of a is b, then the integration of b is a. Right? If the differentiation of m is n, then the integration of n would be m. Obviously, plus constant of integration. Clear? So, in integration, you will be not required to remember the formulas. If you are aware, if you are familiar with the formulas for differentiation, then you can easily remember all the formulas in integration as well. So let's start with the formulas and revise the differentiation formulas as well, right? So let's start with the first case. Look. Differentiation of x to the power n plus 1. Make use of the formula. What is the formula? It is n plus 1 x to the power n plus 1 minus 1. So what do you get? N plus 1 x to the power n. This is the formula. And this is nothing but it has come from differentiation of xn. It is equal to nx n minus 1. dx by dx. That need not to be written because it is equal to 1. Right? Here also it will be dx by dx. That is unity. So no need to write that. So this is the master formula. From this we can obtain the differentiation of x to the power n plus 1. It would be n plus 1 x to the power n. So this is it. Right? No doubt regarding this. Now, just now we have discussed, differentiation of this term is equal to this. Therefore, integration of this term would be equal to this. Right? Therefore, Suppose this is A, this is B. Differentiation of A is equal to B. Therefore, integration of B would be equal to A. Therefore, integration of n plus 1 xn. Here you are supposed to write with respect to x. It would be equal to xn plus 1. Clear, students? And also, n plus 1 being constant, it can be written like this, n plus 1. So, this is the first formula for the integration. X to the power n dx, it would be equal to x to the power n plus 1 divided by n plus 1. Obviously, plus constant. You can write over here plus constant. Here, this you can introduce in the last step. This will be the constant of integration. This is the first formula. And students, remember one thing. This formula is valid only when n is not equal to minus 1. I'll give you the reason. For n equals to minus 1, look over here. For n equals to minus 1, what we get is, it will be 1 by x dx. Isn't it? It would be x to the power minus 1, which can be written as 1 by x dx. And it's having a different formula. How? I'll tell you. We are aware of this formula. Differentiation of log x is equal to 1 by x. I'm talking about the natural log, right? Therefore, integration of 1 by x dx, it will be equal to log x. Understood, student? This is another formula. This is another formula. So, students, this is the basic formula in integration, and this is valid only when n is not equal to minus 1. N can have any other value, right? For n equals to minus 1, this is the formula to be used. For n equals to minus 1, it will become x to the power minus 1 dx, which in turn may be written as 1 by x dx, whose integration is log x. You can derive it by that formula for differentiation, right? So this is the first formula. Let's try to derive some other formulas as well. So we are aware of other formulas of differentiation. Differentiation of sin x is cos x. Differentiation of cos x is minus sin x. So let's make use of those formulas, right? So differentiation of sin x with respect to x, it is cos x. Therefore, integration of cos x, you are supposed to write over here with respect to x, it would be equal to sin x. Plus, obviously, introduce this constant of integration, right? This is the second formula. So look, if the differentiation of sin x is equal to cos x, then the integration of cos x would be equal to sin x plus constant of integration that has to be introduced in the case of indefinite integral where the limits are not given. Okay, another formula. Differentiation of cos x, it is equal to minus sin x, which implies that integration of sin x with respect to x, this minus sign can go to the other side of the equation, so it will become minus cos x plus constant of integration. It's clear now? Differentiation of cos x, we are aware it's equal to minus sin x, therefore integration of sin x would be equal to minus cos x, right? Just now we have discussed differentiation of log x is equal to 1 by x. Therefore, integration of 1 by x with respect to x, it will be equal to log x plus constant of integration, right? Next, differentiation of e to the power x, it is equal to e to the power x. Therefore, integration of e to the power x with respect to x, it would be also equal to e to the power x plus constant of integration, right? And I'll write that basic formula as well. Differentiation of x to the power n plus 1, it is equal to n plus 1 x to the power n, which implies that integration of xn with respect to x, this term will go to the other side of the equation, so we'll be left with x n plus 1 divided by n plus 1 plus constant of integration, and for any value of n except when n is equal to minus 1. So students, I sincerely hope that you will be easily able to remember or retain these formulas, isn't it? So it's pretty simple. So again I repeat, integration is a process of obtaining function from the derivative. So that is the reason why integration is said to be an inverse process of differentiation. So if the differentiation of a is b, then the integration of b would be a. That is what I have done over here, right? So there are some other important results as well which we will try to discuss. So in case u is a function of x, v is a function of x, w as a function of x, and if we are supposed to find u plus minus v plus minus w dx, so simply open the bracket and we can write like this: integration of u dx plus minus integration of v dx plus minus integration of w dx, right? So this is another way of expanding it. Clear? So these were indefinite integrals where the limits were not given. Now let's discuss definite integral. Here the limits will be given, lower limit and upper limit. If integration of fx dx is equal to, suppose it is f dash x. Let us consider the integration of fx with respect to x is f dash x. Then integration of fx with respect to x from lower limit to upper limit, from say a to b. This is known as the lower limit and this is known as the upper limit. It will be given by, after obtaining the integration, simply substitute upper limit minus lower limit. That is, upper limit in place of x it should be written as b minus lower limit f dash, lower limit is a. So this is it. This is known as the definite integral. We will discuss numericals based on it, and also we will try to apply the limits so as to get the numerical value of certain integrals, right? So let's proceed with some questions. Let's try integration of few questions, right? So question is, suppose find out the value of, let's discuss the first question. So suppose it is given to be x square plus 3x plus 1 dx, right? This needs to be found, and suppose the limits are from 1 to 2. These are the limits given. So initial to start with, forget about the limits. You need to first solve it. So what to do is, you can write it like this: x square dx plus 3 can be taken outside, x dx plus 1 dx. Limits will be from 1 to 2. Right? Let's apply the formula. Now, what's the master formula? We are aware this is the master formula. X to the power n dx is equal to x to the power n plus 1 divided by n plus 1. So, what do we do over here? It will be x 2 plus 1 divided by 2 plus 1. 1 to 2. Clear? Plus 3 big constant can be taken outside. X to the power 1. N is equal to 1 over here. So its integration will be x 1 plus 1. Simply the denominator would be same as that of the power. Right? So just remember, here it's 2 plus 1, denominator also it's 2 plus 1. 1 plus 1, it will be n plus 1, again the same. Limits are written in this particular manner. Plus 1, this is very important, students. 1. Can it be written like this? X to the power 0. Anything to the power 0 is 1. So what to do is, it will be x 0 plus 1 divided by 0 plus 1. So what do you get? X cube by 3, 1 to 2, plus 3, x square by 2, 1 to 2, plus x to the power 1 divided by 1. Simply we get x, 1 to 2. So directly remember, integration dx is x, integration dy is y, integration dz is z. So remember these results. Integration of dx, it will be simply x. Integration of dy, it would be y. Integration of dl, it would be total length. This is small length, and on integration, on adding those small lengths, we will get the total length. So that is how we need to proceed. And that I've justified. How dx integration is equal to x. Right? Now in the last step, let's substitute the value 1 by 3 being constant can be taken outside. Now look, upper limit minus lower limit. 2 is the upper limit, 1 is the lower limit. So what do you get is, in place of x, write 2. 2 to the power cube minus, in place of x, write 1. 1 by 3 already has been taken as common. So this is the correct way. Plus 1 by 2 being constant can be taken outside, x square. Upper limit minus lower limit. So it will be 2 square minus 1 square. Plus upper limit minus lower limit. In place of x, write 2 minus lower limit, that is 1. Clear, students? So it can be solved. 8 minus 1 plus 3 by 2, it will be 4 minus 1 plus 2 minus 1, that is 1. So 8 minus 1, it will be 7 by 3 plus 9 by 2 plus 1. So it can be solved. 6 is LCM, 3, 2, 14 plus 2, 3, 27 plus 6. So it will be equal to 47 by 6. So this is how we get a definite numerical value. So that is the reason why such integrals having limits are known as definite integrals, because they produce a definite result. Right? So this is how it can be done easily. Let's try some other question as well. We can try some other questions as well. So suppose integration of 3 by root x. Let's start with a very simple one. So 3 being constant can be taken outside. 1 by root x, it can be written as like this. Clear? So 3, make use of the same formula. Integration of x to the power n with respect to x is x to the power n plus 1 divided by n plus 1. So what do you get is x to the power minus half plus 1 divided by minus half plus 1. The denominator will be same as that of the power of x, right? Plus definitely constant of integration, because it's the case of indefinite integral having no limits. So what you get is 3 minus half plus 1, that will give you half, and it is also half, plus c, constant of integration. So it will be 6 root x plus constant of integration. So students, I sincerely hope that such questions can be easily practiced, right? Do as much questions as possible. Make yourself efficient enough to encounter, be prepared to encounter such questions in physics. And there you have to make use of calculus, right? So I will take one more session of this particular topic of integration. There we will be dealing with some actual problems in physics involving the application of integral calculus, right? So till then, do practice all the formulas. We'll continue in the next session.